Now that you see sine and cosine theta right here, I want to ask you all a question. That is, do you still remember the identities like sine square theta plus what? Sine square theta plus cosine square theta is equal to 1. Okay, if you still remember this, that's very good. Okay, I'm very happy. And I'm going to say, hey, do you still remember the other two? Do you still remember the other two with tangent and secant and cotangent and cosecant? And I would say, if you don't remember, congratulations, you are just like me. Okay. But if you don't know them, then you need to know how to get them. When I taught those Pythagorean identities, I said this very clearly. I said, I do not firmly memorize the other two. I know this one, this is easy. I do not remember the other two, but I know how to get the other two. How do you get the other two identities? You divide both sides by, well, either sine square theta or cosine square theta to get the other two equations. So you think about, well, if you divide the first one by, both sides by the sine square theta, okay? And this becomes 1. This becomes cotangent square theta because cosine square theta divided by sine square theta is cotangent square theta. 1 over sine square theta is cosecant square theta. That's the other equation. Okay, that's the other equation. Okay, I mean one of the two. The second one is that you divide the first equation by cosine square theta, which gives you tangent square theta plus 1 equals to secant square theta. So I want to make one point very clear. Is that if you don't know the other two, it's okay as long as you know how to get them. Okay, the method to get them, it's more important than you firmly memorizing these two. I think the first one is kind of easy. Everyone got it. Okay, so will they be useful? We shall see. We shall see. All right, now, so we have these wonderful equations here with sine and cosine, and we have theta now instead of t. So how would things change if we have theta instead of t? Well. Hold on. So what we would do is this. We will go ahead, set up the theta, x and y for the table. And then we say, well, what are some good good theta values? Okay. So let's just say we do 0, and then maybe pi over 4, then pi over 2, 3 pi over 4, and pi. Let's just do these 5 values. Okay. Let's just do these 5 values. I hope you still remember all these sine and cosine values. Okay, let's see how good your recall is. What's cosine of 0? 1. So therefore, for x value when theta is 0, that's 5. What is sine of 0? 0. So y value be -1. Okay. When it's pi over 4, so you have 3 plus 2 times root 2 over 2. So it's basically just 3 plus root 2. And then for y value, it'll be -1 plus 3 times root 2 over 2. So you can just write it this way. -1 plus 3 root 2 over 2. Cosine of pi over 2 is, what's cosine of pi over 2? 0, right? So that means it'll be just 3. And sine of pi over 2, it's 1. So you have a 2 right here. Okay. And then you have 3 minus root 2 in this case, because it's just like the pi over 4, but now in this case it'll be a negative root 2 over 2, so it changes the plus sign to a minus sign. So 3 minus root 2, and then you have the same number, because for sine of 3 pi over 4 is the same thing as sine of 3 pi over 4, and for pi, cosine pi is negative 1, so x becomes 1, and then this becomes negative 1. Okay? Yes. All right, now, so for the graph, so we have 5 comma negative 1 when theta is equal to 0. Now, square root 2, it's around 1.4. Okay. So you can use it as a little approximate. So for theta equals to pi over 4, the x value would be approximately 4.4. But the y value would be, so you can think about 1.4 divided by 2 would be 0.7 times 3 is 2.1. 2.1 minus 1 is 1.1. So think about 4.4 comma 1.1, somewhere right here. Okay. And then you got 3 comma 2 right here. And then this is theta equals to pi over 4. This is theta equals to pi over 2. And then you've got 1.1 again for the y, but in this case, 3 minus 1.4 is 1.6. 1.6 is somewhere here. And then you've got here. So based on the points that we've got so far, that would be the half. Yes. Can you repeat the question again? Like what are the plottable points for 3 pi over 4 would be so that's around 3 minus 1.4, it's 1.6, right? So that's about 1.1. So those are the points. Okay. So for cases like this, we just do our very best. Okay. And we have to label the points. So 3 pi over 4. This is theta equals to pi. All right, make sure you label the parameter all next to the points. So what does it look like here? It looks like a. It looks like a parabola, right? Well, let's see. Let's see if it's really a parabola here. Now, so the next task is to eliminate the perimeter.